Hello and welcome to Oracle Data Guard, Operating System Requirements. My name is Steve Hamilton and I will be your instructor for this course. Please remember, if you have any questions or comments, please feel free to use the question and comment box found below. Okay, let's get started. In this module, we will look in detail at the operating system, the CPU requirements, and the overall physical hardware requirements in the data guard configuration. Because when you're going to deploy data guard, we need two physical systems. We need the primary database and we need the physical standby database, or the logical standby database, depending upon which route you go. But in most organizations, we're going to be dealing with a physical standby database. We're going to look at the CPU utilization, or the CPU requirements. Does the primary and the secondary have to have the exact same CPU requirements? We're also going to look at the memory requirements. What is going to be the memory requirements between both the physical and the primary system? Now, I will tell you this kind of out of the gate, the memory requirements do not have to be the same. And one of the organizations that we did is we did a lot of virtualization with our memory requirements, and it was really kind of cool how we did it. So when we get to that specific section, I will explain the memory requirements just a little bit more. And then we will look at the overall operating system binaries. When we talk about the operating system binaries, really what I'm referring to here will be the differences between a 32-bit and a 64-bit system. And we're going to do the same thing with our Oracle binaries. So again, it's the same thing. Are we going to look at, is this going to be differences between a 32-bit system and a 64-bit system? So overall, we're going to look at what the CPU requires, the memory requires, our operating system, as well as the Oracle binaries. And these are the actual executables. So first of all, let's take a look at the CPU requirements. These are going to be the minimum requirements to run any Oracle database. So whatever the minimums are to run your 10G or 11G database, they must be the same on both the primary and the secondary. What I mean by that is the same minimums. They don't have to be the same CPUs. Obviously, your CPU on your primary can be different than the CPU on your physical standby. That doesn't matter. As long as they're the same base operating system, Linux to Linux, Windows to Windows, those things, it doesn't matter. But they have to meet the same minimum Oracle requirements, which everybody does. The minimums anymore are so low, nobody is going to deal with the actual minimums anymore. And this is exactly what I was saying, is the CPUs in and of themselves can be different between the standby and the primary. So you can have one CPU that's going to be substantially faster than the other, or one can be a 4-way box and the other one can be an 8-way box. It doesn't matter. They just have to be the same base operating system. Certainly our preference would be for the CPUs to be the same. However, there's no specific requirement for them to be the same in any way, shape, or form. For each physical node, we would like to have each physical node configured similarly. They would need to have the same overall configurations. Now, this is one of the things that we did at one of my last organizations, is that we enabled virtualization for our standby databases. In a typical physical and primary and physical standby configuration, a standby database is a completely separate node. I mean, it's a physical box. It's a completely different box. What we did is that we purchased one large box and created virtualization. So we enabled VMware within that box. And so now within that box, we had 4 or 5 other virtual machines. So what this did for us was actually reduce the footprint of this physical nodes or the physical servers within our organization. Say we had 10 standby databases. What we did is we created 2 large servers, and then within those large servers we created 5 virtualization systems. So now we only had 2 physical nodes. We only had to license those 2 physical nodes, and the licensing capabilities within Oracle also went down. So the cost of our servers went down, the cost of our licensing went down by enabling virtualization. Also, when I talked about the memory requirements, typically the memory requirements on a virtualized standby system is going to be less than on your primary system. There is no reason, if your primary system has to have 10 gigs of memory for the SGA, that you should have 10 gigs of memory for the SGA on your physical standby. It just doesn't matter, because the physical standby database is not receiving transactions from your end users. It's only receiving log files from the primary system and applying them. So it doesn't have to be as fast as your primary. And this is exactly what we did with our virtualization. We created multiple virtual servers on one large server and reduced the memory requirements for each individual standby database, and it worked just fine. So my recommendation is, if you're going to implement standby database, also take a real close look at virtualization. What we did was we put our standby databases on virtual servers. The other thing that worked out very nice for us is, number one, it does require less memory, but the other thing is, in the event of a failure and we fail over to a virtualized database, we can increase the memory requirements to the system that we failed over to and reduce the memory requirements for the other standby databases on that virtual server. So odds are you're not going to fail over to multiple standby databases at the same time. I mean, there's a possibility that you'll fail over to one. I mean, you'll have a catastrophic failure for one database server, and you will have to fail over to it, and then make the memory adjustments accordingly. But your odds are you're not going to fail over to all of them at the same time. So it will absolutely require less physical servers, and it will reduce the licensing fees. There will be a substantial amount of savings just on the reducing of the number of servers in and of themselves. We did our cost-benefit analysis on this, and we saved a lot of money. And the question was, well, it's going to cost us a lot more disk space, which is true. It will cost additional disk space, but the amount of money that we saved by purchasing less physical servers and buying fewer licenses totally outweighed the cost of buying additional disk space. So this is something your organization should really seriously consider, is virtualization. This is, like I was saying, most standby databases would not be required all at once. And what we'll do is, if we have to perform a failover, we will adjust the memory requirements as needed when the standby has to be brought up. We want to make sure that we have plenty of storage that's available, and this is what I was saying, is if you enable virtualization, what we can do is the amount of money that we will save by purchasing fewer servers and less licensings will far outweigh the amount of money that we will spend by purchasing more disk drives. Now, the memory requirements between your physical and your primary system, they absolutely do not have to be the same. As a matter of fact, we recommend that they're not the same. Obviously, your primary database is that database that is receiving transactions from your end users. That system has to run fast. It has to run optimal. So we want to put as much memory as we can to the primary database. The secondary database is only receiving transactions from the primary. We do not have end users affecting the secondary database. They're not inserting transactions, or most times they're not running reports. So what we can do on the secondary server, we can really back down the amount of memory that we associate to the SGA for that physical standby database. I highly recommend that you investigate this, because memory is actually quite a bit more expensive than disk. And we can purchase disk all over the place. But the memory, we can still purchase memory, but it's going to cost us a little bit more. So back down the memory requirements on your secondary database and use that memory on your primary system. The SGA between your primary and your secondary can absolutely be configured differently. Certainly we have certain parameters that have to be the same, like DB unique name and instance name and service names. Those have to be adjusted. Parameters like DB file name convert and log file name convert. But when we talk about the overall SGA, the SGA target, the memory max target, the memory target, odds are 95% of the time are going to be different between your primary system and your physical standby system. And this is just what I was saying. We actually recommend to have different SGAs, especially if you're using virtual servers. Again, I will tell you, my recommendation will be when I go into almost any client site, if they're going to be using a data guard configuration, I will tell them to investigate virtual servers or virtualization. It is substantially cheaper and it works just as well as a physical server. Okay, when we talk about operating system binaries, we're saying that they should have similar binaries. We should be converting to a 32-bit system to a 32-bit system, or a 64-bit system to a 64-bit system. We don't particularly want to commingle a 32-bit system to a 64-bit system. So the operating system, we should have the same binaries. We also want to make sure that you have the same operating systems. We're going to convert from, or have data guard configuration from a Linux environment to a Linux environment, from a Windows environment to a Windows environment, from an AIX to an AIX. So we want to have the same operating system binaries as well as the same overall operating systems. All members of the data guard configuration should have the same OS and binaries. So in this, if I have a data guard configuration that is comprised of one primary database and 5 physical standby databases, all 6 of those must have the same OS as well as the same operating system binaries. This statement is going to hold true for databases as well. We want to have the same Oracle binaries, whether it be 32-bit or 64-bit. We just want to make sure we have the same. And then we also want to make sure that we have the same Oracle database versions. So we want to have a data guard configuration of 10.2.4 to 10.2.4, or 11G2.2 to 11G2.2. So the operating systems need to be the same, the operating system binaries need to be the same, the Oracle database versions need to be the same, as well as the Oracle database binaries. This is exactly what I was just saying. The versions of Oracle must be the same. Must be 10.2.x to 10.2.x, both on your primary as well as your physical standby. The big thing that you have to be aware of is verify that there is enough disk space both on the primary and the secondary for archive log files. In a data guard configuration, it is entirely possible to run out of archive log files relatively quickly if those archive log files have not been removed. In the data guard configuration, it will automatically apply the archive log file and delete the archive log file once it has been applied. However, if there's a lag delay on that physical standby database, you can generate a fair number of archive log files. So what I would advocate is make sure that you have enough disk space. If you do not have enough disk space, just like any other database, if you run out of space in your archive log file or your archive log destination, your primary database will suspend and it will hang until it has applied all of the archive log files. That's going to be the same thing. The same thing is going to be true in your physical standby. If you've ran out of space in your archive log destination on your physical standby database, you can no longer receive archive log files, and that will have a significant negative effect on your physical standby database. We want to make sure that the database parameter db recovery file dest is set to accommodate for a large number of archive log files. I believe in an Oracle 11G environment this is now set to 4 gig. In Oracle 10G environment it was set to 2 gig. So what we see here is we look at our data guard configuration, and I can see that I have 2 databases. I've got my ORCL3, which is my primary database, and I have ORCL31, which is my physical standby database. Both of them are up, and they're basically both the same operating system, the same binaries. These are the exact same versions of the Oracle executables. When I drill down into that specific host, I can see that the operating system for that host, for that database, is Red Hat Enterprise Linux Release 4. This is the update version. This is the hardware platform, the number of CPUs, as well as the number of memories, or the amount of memory. This is actually the database, or the host, that holds my primary Oracle database. Now, if I drill down into ORCL31, this is my DataGuard database. This is my physical standby database. I can see that this database is up and running. I can see over here on the right-hand side that it is a physical standby database. The primary database is ORCL3. If I drill down into the console, I can see that this is the exact same type of operating system. It's a Red Hat Linux with a particular version, amount, and memory requirements as well. So, if we take a look at the overall advantages of using DataGuard from an operating system perspective, we can have different CPUs. The boxes do not have to be identically configured. Okay, they have to have the same operating systems. They have to have the same operating system binaries, but they can have different CPUs. They can have different memory requirements. Let's say that you had an old machine out there that was the same Linux machine, but it didn't have as much CPU and had not as much memory. That's the perfect box for a DataGuard configuration. A machine that's a couple years older, and you can use it for a DataGuard. Or let's say, better yet, that you're in the process of upgrading. You ran out of horsepower on this particular server, so you're going to upgrade from this server to another server. If you do that, why don't you just keep that old server around and use that as the DataGuard server? Very, very common. Then you don't have to go out and even purchase another server. So my recommendation is, in that environment, or if you're going to implement a DataGuard configuration and you have to upgrade servers, upgrade the old server to the new server and keep that old server around for your DataGuard or for your physical standbys. Within virtualization, it allows for fewer licenses and hardware. There's a ton of valid reasons to go to virtualization. My personal favorite is the less hardware. Because let's say you have this huge data center. Well, if you have this big data center, you can reduce the physical number of servers. So now you're going down from 20 servers to 8 servers. You can get rid of those other 12. You've got footprint issues, you've got cooling issues, you've got electrical issues. I mean, everything goes down. The amount of electricity that you're going to use, the amount of cooling that you use to cool the data center, the physical amount of space that is required for the data center, it all goes down. So by implementing virtualization, it quite frankly is a win-win within your own organization. So again, I cannot stress enough, virtualization just has so many upsides to it. The downsides are some slight configuration issues, but once you get around those, you're going to be fine. The disadvantages of a DataGuard configuration as it pertains to your operating system is it will require more disk space. I mean, this is definitely going to be true if you've implemented virtualization, but DataGuard will absolutely require more disk space, so please be aware of that. It will also require a higher network traffic. So if you're going to implement a DataGuard solution, I highly recommend that you beef up your network because you're going to be shipping log files from one system to another. The other thing to keep in mind is that these systems could be in different geographical vicinities. So if your primary system is in Omaha and your secondary system is in Chicago, and you're going across a pretty slow line, keep in mind that you're also going to have a lot of latency out there. So make sure that wherever you're shipping the data to, it's on a very, very fast network. In a DataGuard environment, there's no doubt about it, you will have additional equipment cost. Even if you implement a virtualization, you're still going to have to create that virtualized server. So in a DataGuard environment, you're definitely going to have to purchase different hardware. You're going to have to purchase additional box, CPU, memory, beef up your network. So DataGuard does cost some money, but I guess the real question is, how valuable is your data? How important is your data to you in the event of some sort of catastrophic failure to that primary system? The DataGuard is part of Oracle's Enterprise Edition. That is a native feature within Enterprise Edition. If you purchase Oracle Standard Edition, I believe that Data Card does not come with the Oracle Standard Edition, but it does come with the Enterprise Edition. It is fully integrated with Oracle's Grid Control. And within Oracle Grid, basically we go into Oracle Grid under Availability, go through the specific wizard, click Add, and we create a brand new Data Guard configuration. And it will protect against most major disasters. Or all major disasters. The whole point of a Data Guard configuration is it affects against disaster recovery, whether it's Mother Nature, act of God, or whether it's a man-made disaster, a fire or a flood or whatever it is. But the whole point of a Data Guard configuration is to protect in the event that we've lost that primary system. The operating systems that we will support within Data Guard, pretty much any of the operating systems that are out there. We will support all of the Windows platforms, all of the Linux platforms, any sort of AIX platforms. I would say any form of *X platform will be supported in a Data Guard configuration. Obviously, Oracle is going to support the Sun environment because they just purchased Sun within the last 18 months. So Oracle will be fully integrated within the Sun operating system as well. What I've done here is I've gone into the grid control and I've looked at the specific operating system details for my particular host that's going to handle my Data Guard configuration. And I can see that this is a Red Hat Linux environment. It's a 32-bit system. I believe it has about 1.2 gig, and we have a certain amount of swap space available. These are all of the servers and everything, the operating system properties. I can also drill down into this from the grid environment, and I can look at the file systems associated to this specific operating system, as well as all the packages associated to this specific operating system. But all we're showing here is that this Data Guard configuration sits on top of a 32-bit Red Hat Linux environment. And again, what we've done in this particular environment, we've navigated to the file systems and we've identified these are the specific file systems that are within my Red Hat Linux. And I can see that I have 4 file systems, the root file system, the boot file system, the U01 and U02 file system. And then I can look at all of the packages that are deployed to the specific operating system. The bottom line here is this, is that the base operating systems need to be the same. They need to be the same operating system version. They need to be the same operating system binaries. The packages can be different, the file systems can be different, the CPU can be different, the memory can be different, but the base operating systems must be the same, as well as the binaries for that operating system. So the bottom line here is this. We can create Data Guard on a similar OS. It must have the same binaries. It must have the same Oracle version as well as the same Oracle binaries. But we can have different memory requirements as well as different CPUs. Do you have any questions? Please remember, if you have any questions or comments, please feel free to use the question and comment box found below. Thanks for joining us.